Hello, thank you for tuning in. We are continue the tree question. This is choose from the frequently asked questions. You're going to evaluate a tree is a symmetric tree, and this marked as easy question, but the tree question never going to be easy for me. So, but this one indeed not very hard, but it's very good foundation to build your tree, understanding the tree knowledge. For this example, so you could see they are like a minnow, so they are the same. And if you see this one 1 to 2 and this one it is you return false. So they actually expect you solve a recursive and iteratively way, and are going to this way recursive and iterative way better than understand the user validated binary tree. User validated binary tree I use when I do iteratively actually use the stack in here. Well, first do iteratively way. So I'm going to use the queue. So first in, first out, I will push each time, and every time I have root, I just get 2 root. I push the root and push the left and the right. One push compare the left and another root, the same root get the right. I continue working on see if I find any invalid situation. If I find it, I just return false. If I didn't find any invalid situation after looped out, then we're going to return true. So like I said, so I'm going to have a loop. If I didn't find, going to return true. If anything I found inside, when I compare, I return false. Now I'm going to have a queue. I have a tree node queue. So this is my queue. I have a new list linked list. Okay. Yeah. A queue behaving like a linked list. These are explained before I did one. Actually use the linked list achieved. So queue.add a root and queue add root. So actually, and the queue is first in, first out, then I pull out. Every time pull out at the same time, I pull out 2 lots out, but I compare things and first one the left and with the second one left and right, and the first time right with the second time left. So let's start it. So why you have if the queue dot is empty. So you get the 2, and I pull out the 3 nodes. This is nodes 1. So if T1 equal to now, both of it equal to now, then I just continue. But either one of them, one is null, but another one not null. Any one of them not null, I just and return false, because one have a value, another one don't have a value, definitely is won't be balanced. So then looking up, but if T1 dot value also you each time you compare those, they have a value and also have a left and a right. If T1 dot value not equal to T2 dot value, just return false. And otherwise you just push this in, so q dot add. Once compare the root loss, then you compare the T1 dot left. But you remember first in, first out, then you second time be careful, you did add T2 dot right. because you like once you pull this out, you compare with the T1 with the T2 the right, and the same you compare T1 dot right with the T2 dot left. And once you loop everything out, you didn't find it, and then you just return true. I think this code is straightforward, easy to understand, don't need to explain. Just let's test if I have a syntax error. Action it is. So new linked list. This time is accepted. Let me submit see if accepted by other scenario. Yes. This is iterative way, but he said, can you solve also in the middle way? I believe this part of the question trying to build your foundation with the tree. So let's solve it. So the best scenario is so it actually so still you're going to compare two rows. So if they're all equal to null, and then just but if either one of them is not null, just return false. So how are going to do? Yeah, the best scenario, we found the best scenario. So middle function going to call the function itself. So I'm going to return is middle. Still actually similar like previous are two, but then actually you have here we are got two rows. One's T1 dot right and T2 dot left, and also another one also is middle, and T1 dot left and T2 dot right. So you actually this you're going to you get two rows. So how I get two rows actually is and I don't know the in here. Actually I'm going to do like this one. So you actually just return is middle. Okay, and you return root and the root. So you pass the two root in, and then you're going to compare. Then you just write the help function. And then you accept the two tree rows. It is similar like the iterative way. Instead of pushing to tag you pop up, you actually direct send the two root rows in. Then T1 and the tree node T2. In T1 and T2, you just return. You call yourself. You compare T1 dot right equal to T2 dot left. T1 dot left equal to T2 dot right. Yes. So you're going to check if T1 equal to null, and so if the root rows is null, T2 also equal to null. So in this case, you just return true. You see, if this root rows is passed to you to is null, otherwise you're going to loop, going to the end, going to T1. If T1 equal to null, or either one of them, T2 equal to null, then you return false, because one is not null, one is null, then definitely not balanced. And then you're going to check if T1 dot y node equal to T2 dot y, so you also return false. So let's see if T1 is equal to null and all of this one. So if first time coming in T1 equal to null, then you go into T1 dot left, then you compare T1 dot right will be with T2 dot left, and the T1 dot left compare with the T2 dot right, see if they are the middle, then you submit, see if it's satisfied. and it is. So that is two-way solver for this is a symmetric tree lots. Thank you for watching.